The answer will surprise you. One culprit might not be enough. A 66 million years ago, the reign of the dinosaurs ended abruptly. The two primary suspects dominate the debate over this planetary trauma. The first, the massive volcanic eruptions of the Deccan Traps in India. A second, the devastating impact of a massive extraterrestrial object. And now that we understand the two main contenders, let's examine the impact evidence. The strongest evidence points to the Chicxulub crater, buried beneath the Yucatan Peninsula. This impact structure measures over 180 kilometers wide, confirming colossal energy release. But crucially, global rock layers contain iridium, a metal rare on Earth but common in asteroids. The impact shockwaves also created telltale glassy spherules and shocked quartz grains worldwide. The immediate aftermath involved global wildfires and sunlight blockage from vaporized rock dust. This sudden impact winter caused rapid, severe climate collapse, devastating surface life. However, the timeline complicates this simple impact narrative significantly. On the Deccan Traps, eruptions began long before the Chicxulub impact event occurred. These eruptions were not single events, they were sustained, epoch-defining releases of magma. The gases released, particularly sulfur dioxide, caused profound, long-term acid rain and cooling. This slow environmental degradation stressed ecosystems long before the final blow arrived. The key difference lies in the speed and global reach of the catastrophic mechanisms. We find evidence that the most intense Deccan volcanism actually peaked just as the asteroid hit. This raises a crucial question. Did the impact trigger the final, most destructive volcanic phase? The current consensus favors a 1-2 punch scenario, making both factors essential. The volcanoes weakened the dinosaurs' world, making them highly susceptible to collapse. But the asteroid provided the instantaneous extinction mechanism that tipped the balance irreversibly. Our protagonist, Dr. Aris Thorne, dedicated his career to disentangling these two giants. Thorne believed the volcanic signature was often misinterpreted as solely impact-related debris. He focused on trace elements that only massive flood basalt degassing could produce consistently. Volcanism causes ocean acidification and gradual sea level fluctuations, stressing marine reptiles slowly. Impacts, conversely, cause immediate, global collapse through darkness and thermal radiation pulses. And the survival of smaller, burrowing, or aquatic creatures suggests they weathered the initial shock better. Fossil records show a sharp extinction filtering, favoring those less dependent on immediate photosynthesis. But let us return to the Chicxulub site, the ultimate smoking gun for instant catastrophe. The sheer scale of material ejected implies an energy release far exceeding global nuclear arsenals. Only hypervelocity impact can produce these specific crystal deformations seen globally. And this event was fast enough to catch entire ecosystems completely unprepared for darkness. I'll contrast this speed with the Deccan eruptions, which unfolded over hundreds of thousands of years. Basalt layers are discrete, showing periodic bursts, but lacking the signature impact markers. Volcanic cooling and warming cycles allowed some life forms to adapt, albeit poorly. But the Deccan Traps fundamentally altered the baseline conditions for survival long before impact. The convergence of both events provides the most complete explanation for the mass extinction. The large, specialized dinosaurs simply could not cope with prolonged darkness and resource scarcity. Understanding impact physics reveals the true scale of this instantaneous, world-altering strike. On the energy vaporized rock, injected sulfur, and triggered tsunamis across the globe rapidly. But this fine dust circled the globe, creating the months-long impact winter effect. Our mammalian ancestors survived by relying on smaller food chains and insulation from the cold. The sustained volcanism, however, shaped the environment that the survivors inherited afterward. New forests gradually replaced the devastated Cretaceous landscape, fundamentally changing the food web. The volcano weakened the foundation, the asteroid delivered the fatal, crushing blow. It is the synergy between these two forces that best explains the completeness of the extinction. Every sample taken from that boundary tells a story of simultaneous global crisis. For paleontologists continue to map the ecological fallout patterns layer by layer. But this ongoing work pushes our understanding of planetary fragility to new limits. Our planet remains subject to these enormous cosmic and terrestrial forces simultaneously. The Deccan Traps demonstrate that Earth's own engine can cause near-extinction level events. That the asteroid impact confirms that external intervention can reset evolutionary timelines completely. It was the timing of the impact, striking an already stressed world, that sealed the dinosaurs' fate. The resulting firestorms consumed vast forests that the volcanic climate had already weakened. Then came the prolonged cold, eliminating the remaining megafauna unable to find shelter. An evolutionary pressure during this period favored adaptability over sheer size and specialization. The extinction was not a simple choice between volcano or asteroid, it was a compounded failure. Understanding this dual catastrophe teaches us about the complex thresholds of planetary resilience.